take-home quiz I assigned. I was looking over it. Of course, when I made it, I'm like, oh, this is great, this is great, this is great. And I was looking at one of those questions. I was wondering just how well of a background you might have. And it seems like the multi-step synthesis questions, everybody needs a little more practice. So we're going to work on an example problem and might find a mechanism in there. So it looks like about 6 reactions. I see a reducing agent. I see a Grignard. So after step 1, we form our special disonium salt, which falls apart real easy. And so now copper cyanide makes this nitrile. So I had to go back to chapter 18. I mean, I know what it does. And if you just had good rote memory of the slides, you might figure it out. So the Grignard, let me just go 1, 2, 3, 1, 2, 3, and write my Grignard like this. And that thing slams into there. And here's where life gets sketchy. So here's what was in your chapter 18. See how well, kind of liked it when I could pull the screen down. So here's a Grignard, nitrile, slams into there. You get this. You add a proton, it protonates this. Now here's the part that we keep adding more acid, this hydrolyzes into the ketone. And so we went through this kind of quick. It says a Grignard or organolithium reagent can attack the carbon of the nitrile. The imine is then hydrolyzed to a ketone. So how does that occur? I'm gonna just come over here and then I'm gonna erase it so we can keep going with the rest of this problem. So we have I'll draw my hydronium ion this way. That gets protonated. And don't let me put 2, 4, 6, 8, 10 electrons around a nitrogen ever. Gotta put that positive charge there. So this is very analogous, similar to our carbonyl carbon chemistry when we protonated oxygen. Got the positive charge there. And then we could probably imagine drawing a resonance structure where we put those electrons up there and make this carbon a carboxyl cation. So the point of all that discussion is water can slam in there. I draw those electrons jumping up when this occurs. Maybe this is why we didn't go over this mechanism. We can have water grab one of these protons, and that's going to give me some hydronium ion. So now I have this concerted thing going on where these electrons jump down. So this protonated nitrogen here, that's almost like turning an OH into a H2O. We've turned a NH2, which would be a bad leaving group because that's a really strong base. We've seen that sodium amide many times, but if we get it protonated, then it becomes a good leaving group. But now I guess I can draw it upside down. And then the last step's going to be a deprotonation. And I can imagine water or that ammonia. I don't think it really matters. Those electrons jump back down. All right, so you've never seen this mechanism before, and of course the PowerPoint gave you no explanation. So once again, just probably only people like me who want to memorize all these little conversions. But I know a nitrile group can be converted to a ketone. And here we see how. It's easy to see how we get the imine out of it. And just an overall hydrolysis. So it's almost like this does two things. There's also a way to stop it here, or to go from here to an amine. There's another way to go to an amine if we chose. But if we add water, we can hydrolyze the amine back into the ketone. And you might remember from the chapter on ketones, we could react a ketone with ammonia and get the amine. So it's kind of an equilibrium hydrolysis thing going on there. All right, so now that we've gone that far, let's get rid of the mechanism. So now what is sodium borohydride gonna do for us? Sodium borohydride reduces ketones into secondary alcohols. All right, now this step here, I think you've been thrown off by it before. Maybe the key here is this heat. I'll just come down here and draw in this mechanism a little bit. Guess we're going full mechanism. This is now a good leaving group. Carbocation here. What are carbocations known to do? They do rearrange, but benzyl carbocation, that's like the most stable carbocation. They do one other thing. They eliminate a hydrogen. So I'm gonna draw my catalyst. Well, it was my catalyst. Grabbing that proton, those jumping down, double bond, 2 more carbons. Any questions about this? So I just pulled up your take-home quiz. Number 6. Show how one might synthesize phenylacetone using toluene, sodium cyanide, and any other necessary reagents. So you might want to start with the phenylacetone and do a retrosynthetic analysis. Any questions on this? Made the disonium, made the nitrile, reacted the Grignard with the nitrile, made the amine, hydrolyzed the amine to the ketone, reduced the ketone to the secondary alcohol, and then this, we did an E1 elimination to get to the alkene. So a good question with putting all of our tools we've learned the last 2 semesters together. I wanted to finish the chapter 22 slides, but I have one more example problem, but we'll adjourn early.